Okay, welcome back to the second part of our video. So we already have our beams, our columns all set. Now we're taking the columns to the upper floors. So what you want to do is to select from right to left. Then on this right hand you touch edit and you touch copy. Now we have the X, Y and the Z direction. Since we are dealing with vertical movement, we're going to manipulate with the Z direction. So we'll put 0, 0, Now the distance from the foundation to the ground floor is what we'll put now in the Z direction. And since it's going up, it will be positive. Now we want to copy. So we copy it by 3 meters. And yes, one time, and we execute and we close. Now we select the nodes. Since it's 1.5 meters, we want it to be 3 meters for the columns. So we select the nodes, we do the same thing, but now we are instead going to move, and we're going to move down by negative 1.5 meters. So it will be 0, 0, negative 1.5 meters. That's the distance we are going to move downwards. And if you execute, you see that it has moved and joins with the one below. So while the nodes are still selected, we're not supposed to have nodes on this region. So we're going to touch support. Mind you, the nodes are selected, and we delete just those nodes and we close. So now we have moved this column up to the next floor, but if you highlight it, it's still showing foundation, which is not supposed to be so. It's a very common mistake you get while working with robot structural analysis. But no worries, it's very easy to manipulate on that. All you have to do is select the columns which you want to edit their level. It is very important that you align each column to the level that it's supposed to be. So you come under story and you change it from foundation to ground floor, and there we have it. If I touch ground floor, you see, touch foundation, you see. And if I want all to show at once, I double click again. So moving on, we're going to now copy and align to selected levels for the beams and the floor or reinforced concrete slab. So all you need to do is to select all completely and make sure you always check to see that it's selected. You copy, you use the Z direction, 0, 0, 3 meters. Make sure copy is turned on. Repetitions, I want it to go up 3 times. That's 1, 2 and 3. So I'm going to change this to 3. Not really. I'm going to change this to 1 because I need to apply load on the slab before I continue changing it. So I'm going to change this to just 1 and I execute it. Okay, so if you look closely, you notice I've deleted the slab on the foundation level because normally it's not supposed to be there. The slab is supposed to be on the ground floor because that's where the first water tank will be, and that's where the second water tank will be on the first floor. But down here we don't need the slab. So moving on, the next thing is to apply load. I'll be applying load on this slab. that's highlighted in blue. And before you apply load, you have to first define your loads. Mind you, that all dead loads. So the first is always natural, self-weight. That's self-weight for the slab itself. And then we now define the second one, which is, you can choose to name it however you want to name it. I would say water load. Water load. And I add, make sure dead load is turned on, nature, dead load, and it is structural. So you add that, make sure you don't add twice, and then you click close. You can choose to add another load, so in case maybe you want to add some load. Oh, we have to add roof load for our second, because for the chaining beam which doesn't have a slab, there's going to be the roof, and the roof load is different from the water load. So we choose to, that's how we choose to differentiate it. And we add it again. Mind you, there's going to also be live load. We can also include live load, because the water tank, in order to, for maintenance and the rest, humans also have to be climbing on top of the water tank, even during the installation process. So we can change it now to live, and then we also say water load, water tank load. And then be close. So now we're going to apply load on this slab. Now mind you, this is a 5,000 liters water tank, which is equals to 5,000 kilograms. So we have to convert this to kilonewton, and converting to kilonewton, that's weight, multiply the mass by the gravity, that's 9.81, which gives us approximately 49,000 and something newtons. Now we work with kilonewtons. Converting to kilonewtons will be 49.05 kilonewtons. Now we have to convert this kilonewton to kilonewton per meter square. That's where the surface area of the slab comes in. The surface area is assumed to be 2.5 by 2.5, which is approximately 6.25. So I'll approximate my surface area for this slab to be 6 meters. So we're now going to divide force all over area to get the pressure in kilonewton per meter square, which will be the unit of load we'll be using to apply the load. So dividing 49.05 kilonewton by 6 meters gives us approximately 8.18 kilonewton per meter square. And applying that load, I take surface, because we're applying it on a slab, I take there, and when you're applying load, you always make sure you apply on the Z direction negatively, and because negatively means going down, so I'm going to use the Z direction to apply my load. As I earlier mentioned, negative 8.2 kilonewton. 18 kilonewton. So that is the load. And make sure before you apply that load, make sure you've highlighted your slab first. It's in blue. I highlighted my slab first before applying the load. There's a mistake somewhere. I need to change this to kilonewton per meter square. Oh, kilopascals is actually the same as kilonewton per meter square. So everything is set. All I have to do is to click once, add, and apply. You see the load is showing there. and I close. You don't click more than once. Now if you want to check if the load has been applied, you click on load symbols and you click that, and you see that it has been applied on the slab. So the next thing, we change it now to water tank load. We change it now to water load. Yes, so before you apply load, the first thing is to make sure you are on the load that you want to apply. And if you want to check to make sure you confirm with the right load, you go back to load types, you discover that dead load, which is the self weight, we have the water live load. I differentiated live load so that I was able to differentiate when I'm applying the loads. And this is the water tank load structural. The structural here means it's a dead load, and this LL that has category A, it means it's a live load. That's how you differentiate. Always differentiate. For example, if you're doing water tank live load, water tank dead load. So now I have to apply the live loads on the slab. So water LL, and for the live load, we're dealing with humans. I always like to use 1 kilonewton for my live load on anything, be it beams, slabs, or anything that has to do with roofs. So for the live load, I'm going to use 1 kilonewton. So it comes to load definition, surface, and like I mentioned, load is always acting downward, so we'll put it negative on the Z direction. So negative 1 kilonewton per meter square, and apply, close. If you want to look, if you have applied it, you on this and you on this. Oh, I made a mistake. I did not highlight this before applying the load, so you see it did not actually go. So we do the whole process back, surface, and you apply, close. It has now applied. If you on it, you see it. If you on simple cases, you see I've applied. Simple cases shows you the total loads that you have applied, so it's showing that I've applied just 2 loads. So I am on the right track. Always make sure you do not double apply load, because if you click twice, the load is going to appear 2 times, meaning double load, and your results will be wrong. So mind you, I am on simple cases. Simple cases shows you all the loads that you have applied on your project. I'm on simple cases, and I have aligned to selected levels all my columns and my beams. And the reason why I wanted to apply the load on the reinforced concrete floor before sending up is because whenever you're sending anything up, it goes with whatsoever load you have applied. So I didn't want to apply load 2 times. That's why I decided to apply all the load on the reinforced concrete floor before sending it up to meet with this other load. So that's it. So right now I need to just add 1 more column here for this, and then apply loads on my chaining beam, which will be the load of the roof, which is approximately 1 kilonewton 2 for the dead load, and also 1 kilonewton 2 for the live load. And I'll be ready to analyze my structure.